Hi friends, this is Maximum and today we are going to do some more limit problems. So let's start with the trigonometric limit. The limit as x approaches 0 of cotangent of 2x or cosecant of x. So we can write this cotangent 2x as cosine of 2x over sine of 2x. Then we can divide this by cosecant 2x, that is 1 over sine 2x. So we can make this jump up here. So this becomes cosine 2x sine 2x. Oh, it is sine x, and here also it's cosecant x only. This becomes cosine 2x sine x. This is cosine 2x sine of x over sine of 2x. And x approaches 0. Here our actual limit was x approaches 0. So I write it on the top, x approaches 0. So still this function is not defined. As when you put values, you'll get sin x is 0, so the numerator will be 0. Sin 2x is also 0, the denominator is 0, which is very common in limits, as limits are not so simple always, and we need to solve this further. This function can be redefined like cosine 2x sine of x over sine 2x is 2 sine x cos x. Now x approaches 0, and I'm telling you again and again, x approaches 0 means x is closer and closer to 0, but x is not equal to 0, never. So sin x is also not equal to 0, so we can cancel these out from the numerator and denominator, and we are left with cosine 2x over 2 cosine x. So this is cosine 2x over 2 cosine x, and x is approaching 0. So now we see whether it's defined or not defined. Cosine 2x, that is cosine 0, is just 1 over 2 cosine x. 2 cosine 0, that is 2. This is our actual answer to the limit, 1 by 2, and answer is 1 by 2. So I write the answer and the question again properly. The limit as x approaches 0 of cotangent 2x. Cotangent 2x over cosecant x. Cosecant x is just 1 by 2. Well, in some limits like this, we need to apply some trick, and then we can solve the question easily. So we'll move on to the next one. Now the question is the limit as x approaches infinity of root x square plus 4x plus 1 minus x. Now here, this, don't be tempted that 4x is negligible here in front of x square, so this will cancel out to be 0. 1 is also very small, so this will also cancel out to be 0. We'll just be left with root x square, that is x minus another x, so we'll get 0. Now that is the wrong solution, as you'll see in a meanwhile that we are getting some other value of the limit. Limit as x approaches infinity, root x square plus 4x plus 1 minus x. Now here in this limit, what we do is we have another trick. This is up to here only. We multiply and divide by replacing with plus here. So what we get is the square will be removed. There will be identity a minus b times a plus b would be used. So we'll get x square, x square plus 4x plus 1. This is x square plus 4x plus 1 minus x square again. So that becomes a bit easy for us. Over square root x square plus 4x plus 1 plus x. So we cancel out these x squares and that's better. So we are left with 4x plus 1, and in the denominator there is some irrational. So we'll multiply this by 1 over x, divide by 1 over x. So that is our new trick now. 4x times 1 over x is just, I erase this, to 4x times 1 over x is 4, is 1, so we get another 1 over x, or here inside the root this will get to be over x square everything, and here over x. So we have written this like this. So this can be written as root 1 plus 4 by x plus 1 by x square plus 1. Now we can see that x approaches infinity from the question. Here x approaches infinity. So I write this in a different color. Limit, ignore this equal sign, x approaches infinity. Now whenever x approaches infinity and x is in the denominator, say 1 over x or 1 over x square, 1 over x cube, then this goes to or tends to 0. So that was just an intuition of how we'll do this question. Now let's cancel out the terms which approach 0. This 1 over x approaches 0, 1 over 4 over x also approaches 0, 1 over x square approaches 0. So here we're left with 4, here we're left with root 1, that is 1 plus 1. So 4 over 2, that is 4 over 2, that is 2. So the answer to this limit is 2. This is how we apply some tricks in the limit questions. We have time to take another limit problem. So let me write the question. The limit z approaches 2 of z square plus 2z minus 8 over z to the 4 minus 16. So first we substitute z as 2 here, and what we get, we can see 0 over 0. So that is not defined. Here I'll write the answer which we get when we substitute z as 2. That means we need to do something else. Well, the only way that we can see here is first factorize. The upper one factorizes to be here. If you apply a bit of brain, you'll get this is z plus 4 z minus 2 over this is of the form a square minus b square. So write this as I'm in the habit of writing x every time, so I rub it off. Z square plus 4 z square minus 4. this is z plus 4 z minus 2 or z square plus 4 z minus 2 z square minus 2 z square minus 4, here it is. So write z minus 2 z plus 2 z minus 2 and z plus 2. Sorry, this is short of the screen, so I'll minimize a bit. Here we can see that z minus 2 and z minus 2 are common. The limit is as z approaches 2, and again I am telling you z approaches 2 does means z is not equal to 2, so we can cancel these out easily. So I'll do this in a different color so that we don't pay attention to these anymore. Now what is left is z plus 4, z square plus 4, z plus 2. Now we can substitute the values. Z is 2. 2 plus 4 is 6. 2 square plus 4. 4 plus 4 is 8. And then 2 plus 2, that is 4. This becomes 6 over 24 or 1 over 4. Not 6 over 24, it is 6 over 32. 6 over 32, 3 over 16. That is how we solve these limit problems. In the next video, we'll discuss something interesting, the squeeze theorem. Bye till then, take care.